Hello there YouTube, welcome to my second video on this series. I decided to record this video simply based on popular requests from some of my students. So yeah, I hope you enjoyed this one. This is one that you are probably very likely to come across this in your Ccna exam, and this simply is a NAT sim. And the question is pretty similar to what you're about to encounter in the Cisco exams. The only difference is that I've taken out a frame relay switch, which is located right here. I've taken out the frame relay switch right here out. That is the only difference here, but apart from that, everything works fine. It's also pre-configured as you would see in the exam. So yeah, I hope you enjoyed this one. Without further ado, let's just start doing some configuration. In the exams, you're gonna use a PC to log into the router. So I'm gonna do the same thing right here. So let's go for it. Okay, here we are. I want to log into the PC's terminal emulation software, and here I am in the routers console. I should have changed the background, so let me go straight into the router instead. Yeah, that's a bit more appealing to the eye. So let's do this. First of all, we will be configuring NAT. Okay, we've been given the question here, and let me read the question to you. A network associate is configuring a router for the Weaver company to provide internet access. The ISP has provided the company 6 public IP addresses of the following. That's 198.180.184.105, and the upper range is 198.18.184.110 and /28. You also have 14 hosts within the network, and you have 192.168.117 to 192.168.100.3, all /28. That /28 means 4 bits have been borrowed from the default class C. Okay, so we're going to end up with a block size of 16. For those of you that don't understand what I mean by block size, check out your subnetting skills, but also watch out for a subnetting tutorial coming from me on the same channel. Okay, all right, now let's go and do, first of all, before you start configuring your NAT, first the things to consider is you have to define your NAT pool. Where you've been given a range of global IP addresses, define your NAT pool. All right, and then create a standard access list. The next you do is bind the standard access list, all right, with your pool, the pool that you defined in the IP NAT configuration. Okay, so let's do this. First of all, I want to say IP NAT, okay, pool. Let's call this NAT pool. Yeah, NAT underscore pool. Okay, and we put our addresses there. We've been given global address as 198.108.184. Okay. Oh, sorry. .198.1.184. I beg your pardon. 184.105. Okay, so that's our lower end of the global IP addresses. The upper end of the IP address will be 198.108.184.110. Okay, next we need a net mask command. Yeah, that's the keyword you need to put in there. Okay, net mask, and then you define the subnet mask of the global IP addresses. And because it's a /28, we have a 255, all right, .255.255. 128.248. Okay, 4 bits have been borrowed. You know that when 1 bit is borrowed, the mask is 128. When 2 bits are borrowed, the mask is 192. When 3 bits are borrowed, the mask is 224. All right. When 4 bits are borrowed, it's 240. Okay, I beg your pardon. So 240, and that's the subnet mask. Okay. Let's see what command we need next, and that's it. We've defined the pool. Okay. The next is to define a standard access list. Okay. Access list. Let's use 10. Or let's just say standard access list 1. Yeah. You want to permit the internal networks. So we have 192.168.100.17. Now the trick here is that, and again, your knowledge of subnetting comes into play here. The trick here is that we want to define, we've been given a range of address. Now if we look over here, 17, all right, is a host name. All right, it's not a network address. So we have to then find the subnet to which the 17 host address belongs to. And because this is a /28, we know that we have a block size of 16. All right, 4 bits been borrowed. That's 128.64.32.16. Okay, so 17 here, all right, is the subnet. It is the host address, the first host address of the subnet 16. Okay, so let's go back. So over here, rather than defining, the mistake I came across as I was teaching this was that students or people all often use this address, that's the host address. Now you don't want to define a host address, you want to write a subnet, a network address, okay, and a wildcard mask. That's what you want to do. Okay, so network address is 16, and then our wildcard mask, remember, block size is 16 because /28 is being used. 4 bits have been borrowed in this subnet, okay, to create this subnet. Now block size is 16. Wildcard mask is always 1 less the block size. So our wildcard mask for this access list will be 0.0.0.15. Remember this, okay? Now we have defined our access list. The next command we need is IP not inside source list 1. Okay, and then we need our pool. We called our pool, I think it was nat pool, wasn't it? Nat underscore pool. Okay, that's the name we gave to our global IP address pool. Let's just go up and verify that. Oh, where are you? Where are you? Okay. Where are you? Where are you? Where are you? There we are. Okay, so we defined it as nat pool. Yeah, nat underscore pool. And so we call on that pool. All right. What do we need? We need the overload keyword. Okay. Okay. Now let me explain what is going on here. We say that for the NAT translation to work, we want the source address for the inside network to come from the access list 1 we defined earlier on. We created an access list 1, a standard access list 1. And we're saying that access list 1 contains the source IP, internal IP addresses, or inside local IP addresses. Now we want that to be translated or to be linked to the NAT pool, which contains the 5 global IP addresses that the internet service provider gave to us to use. Okay, now we put the overload keyword there. also because we have 14 internal hosts. We only have six external IP addresses. If we don't use the overload keyword, when six or more than six hosts within the network want to access the internet, all the global IP address in the pool will be engaged. And so the seventh host within the network wouldn't be able to access the internet. But by using the overload keyword, we define the pool, all right, to use sequence and port numbers to track traffic leaving the internal network. That's pretty much what is happening. And so that allows all the networks within the network to be able to be translated across the internet. Okay, so this is why we need the overload keyword. All right, I hope this one is clear. Remember, where you have less global IP addresses than the internal IP addresses, the overload keyword is important if you want every device within the network to have internet access. So that is done now. That is all the configuration we need for our NAT translation. Okay. Now, the next thing we want to do is to define our inside and outside interfaces. So let's do this. Interface serial 0/0. Okay. IP NAT outside. Okay. Why? Because if we look over here, serial 00 is the interface that leads to the outside, or that leads to the internet. Okay, so this is what we need to configure. Define that as an outside interface. The inside interface will be the interface where the LAN is located. Okay, so interface FA0/0 IP NAT inside. All right, and that's it. Okay, we've defined both. Okay, now let's do some testing. Okay. Oh, see, I'm typing testing. Okay, let's do some debugging. IP NAT. Okay. Oh, we've turned NAT on. Let's do some testing and see. First of all, let's ping around and see if traffic is working. Okay, so we have success. Okay, this has failed. Why has it failed? Because this is like a stub network. A stub network is a network with only one interface facing the internet. Pretty much, that's what a stub network is. So over here on this router, we need to define a default route, all right, to direct traffic that are unknown, all right, to the internet, or traffic arriving here bound for the internet to be translated or forwarded to this link. Okay, all right, so let's do this. So configure terminal conft IP route 0.0.0.0 and 0.0.0, yeah, .0 interface serial /0.0. Okay, we've defined that. If we come here, we can then define exit IP route 0.0.0.0 0.0.0.0 serial 1/0. Okay, so we've also defined the default route back into the internal network. Okay, so now let's try and ping again. Okay, let's do this again. We have serial 01. Let's see. Serial 10. Okay, let's do some testing and see. Okay, so that's a success. All right. Now let's do our debugging here. Now you can see that NAT is working because our debug command is allowing us to see what has been happening on the router, and we can see that the internal network 192.168.118 has been translated, okay, to 198.184.105. That is one of our global addresses, and you see the port numbers or sequence numbers here. Okay, all right, let's do some pinging. Okay, let's ping 192.113. Okay, and there we go. Let's look at the translation. Okay, now let's look at this. Let's do some show command. Do show IP NAT statistics, yeah, or translations. Let's do translations. Okay, there's nothing in the translation table because all the translations that took place has expired, and so it's empty. Let's try that again, and you will see the translation working. Okay, let's go back to the router and issue the same command, ipnat trans, and now you see that the translation table has all this information. We can also look at ipnat statistics. That gives you a snapshot of all the hits that your NAT pool has had. Okay, so this is basically how to configure NAT for service for the internet access. This you're bound to come across in your Ccna exam. Okay, I hope you have enjoyed this quick tutorial. God bless you for watching, and spread the news. Also, email me with your questions and contributions. Thank you very much, and stay tuned for more coming your way from my channel. My name is Isaac Opoti, a Ccna and a computer network security professional. Take care of yourself. Bye.